in this video we're looking at rates of reaction, and we're specifically going to look at the preparation of oxygen. So to begin, we'll define what a rate of reaction actually means, and we will look at the experiment that monitors the rate of the production of oxygen from hydrogen peroxide using the catalyst manganese dioxide. So to begin rates of reaction, we need to understand that chemical reactions occur at different speeds. So for example, explosions are usually very fast and iron rusting is very slow. So to describe this differing speeds, we use the term rate of reaction. So it's used to describe how quickly a reaction occurs. Now it's important to understand the definition for the rate of the reaction. So the rate of a reaction is defined as the change in concentration per unit time of any one product or reactant. And this can be given by a formula of the volume of your product over the time taken to produce that product. So in this video we're going to look at the production of oxygen, and as you can see here I've drawn a diagram for us to show the equipment that's used in the production of oxygen. So we have some dilute hydrogen peroxide here in a inverted conical flask, and at the neck of the conical flask we have manganese dioxide. And as we can see here, we have a delivery tube that goes into our beehive shelf and up into our graduated cylinder where our gas is collected. Now we can also see that our gas is being collected through the downward displacement of water, because our graduated cylinder is completely filled with water and also its opening is below the level of the water. So as the oxygen gas gets produced, it pushes the water out of the graduated cylinder and into the water trough or the water basin. So this shows us the property that oxygen is insoluble in water. Now some of you may ask, how is the reaction started? So to start the reaction, you would set up your experiment as it is here with your inverted conical flask. And what you would do is, once you want to start the reaction, you would flip your conical flask 90 degrees anti-clockwise so that the manganese dioxide will drop into the hydrogen peroxide, and you would start your stopwatch and start timing how long it takes for different volumes of oxygen gas to be produced. So some key points just to go back over. You set up the apparatus as per the diagram we've just discussed. You lower the conical flask to the vertical position so that the manganese dioxide and the hydrogen peroxide can react, and then you record the volume of the gas present in the graduated cylinder at regular intervals. So here's some sample questions that may appear on an exam paper. So describe the appearance of the manganese dioxide. So the manganese dioxide is a black powder. Another question could be, what property of water allows for the collection of our gas over water? And I've said that already, that oxygen is not very soluble in water, so it can be collected through the downward displacement of water. The hydrogen peroxide is said to be 20 volume. What does this mean? So when we say the hydrogen peroxide that we use in the experiment is 20 volume, we mean that a certain volume of hydrogen peroxide would give off 20 times that volume when it decomposes or breaks down. Another very common question is uses of chemicals in our experiment. So what is the use of manganese dioxide in everyday use? It's used in the manufacturing of dry batteries. And to finish, name the products of the decomposition of hydrogen peroxide. So when hydrogen peroxide decomposes, it goes on to form water and oxygen. Now, in an experiment like this, you would have a results table, and as we can see here, we have time recorded in seconds, and then we have the volume of oxygen produced at each time interval. So we can see at 0 seconds, there is no oxygen produced. That's because the reaction hasn't started yet. But what we can see is that at 15 seconds, we've produced 60 centimeters cubed. At 30 seconds, we've produced 110. Now, if you look for a trend here, you can see that as we go up towards 120, 150 and 180, we can see that the volume of our oxygen is not increasing at a steady pace. So when we graph it, we actually end up with a graph like the one I've just shown. So we can clearly see that we have a sharp incline at the start that levels off as time goes on. So our rate of reaction is decreasing as we go through the reaction. And this is because at the beginning there's lots of both of our reactants to react, but as our oxygen gets produced, there's less and less of our hydrogen peroxide left to react, so the volume of the oxygen produced will start to stabilize. Now, a very common question here would be to find the instantaneous rate at a specific point in the experiment. So to find the instantaneous rate at a specific point, let's say at 60 seconds, what you need to do is you need to draw a tangent to the curve at 60 seconds. And what you basically need to do is you need to do the rise over the run. So you would do the rise over the run. So I can see that the rise here is approximately 140 up to 200. So that's a rise of 60. And the run is from about 45 down to 100. So that is a run of 55. So to find the instantaneous rate, you would do the rise over the run, which is rise of 60 over a run of 50, and that would give me just under 1.1 centimeters cubed per second. Now we go through this instantaneous rate in more detail in the average versus instantaneous rate video. So if you're still unsure about this calculation, head there for more of an idea. So just some summary questions to finish off. Why does the graph get less steep as the reaction progresses? And I've addressed this already in the previous slide. It's because the concentration of the reactants drops as they get used up and products are formed. And how would we know that the reaction has gone to completion? Basically, the line on your graph becomes horizontal, and this is because no more of your product is being produced because all of your reactants have reacted. That's it for this video. Have a read over the learning intentions to make sure you understand everything.